Lesson 8.2, Task 5. This is the final task. All right, it says construct functions for transformations of the absolute value function. Jen is making a bank shot in a game of pool on a regular size table that has playing field of 46 inches by 92 inches. Using a coordinate plane to describe the location, the cue ball is at -33 before she hits the ball as described. Write an absolute value function whose graph models the path of this cue ball. Jen hits the ball to bank off a side at point 1023 and hits another ball located at 2018. All right, so if you graph the 3 points given, -33, 1023, and 2018, you're going to get the graph here, okay? So this is the initial ball. This is where she hits the ball. She banks it off the side and hits the ball at 2018. All right, so the vertex of the graph is at 1023, and H and K would be 1023. All right, so the coordinates of the vertex, H and K, describe which point in the situation. So that is the side, that's where she banked it. So the point where the cue ball starts, the point where the cue ball banks off the side of the table, or where the ball strikes the other ball. So that would be the point where the cue ball banks off the side of the table, because this is the initial ball. She banks it and hits the other ball. All right, the slope between the initial point and the vertex is given. So you can see they did difference of y's over difference of x's, and they got 1/2. So it says choose the words to correctly complete the statements. The slope of the segment connecting the vertex and the final point is, so the vertex and the final point would be the opposite slope as just found, because remember, a V-shaped graph, your slope, if it's going positive here, it would be going negative back down. If you use the slope of the segment connecting the vertex and the final point to determine the value of A, the result would be A same as the value of A obtained by using the slope. So the A doesn't change. A determines whether it's positive or negative, but the A value itself does not change. All right, so the graph is a vertical compression and reflection across the x-axis of the graph of the parent absolute value function. Choose the word to best complete this statement. The graph is a reflection of the graph of the parent absolute value function when it has a maximum value. All right, so remember, when you have a V-shaped graph, originally a V-shaped graph, it would have a minimum value, but if you have a reflection, okay, then the V is upside down. Now you would have a maximum value. All right, so A is -1/2. An absolute value function that models the path of the cue ball is given by g of x equals -1/2 times x minus 10 plus 23, but the domain must be restricted to match the situation. The domain is restricted to -30, 20. So if we look up here at the graph, we can see our domain comes from our x values. So you can see that the domain goes from -30 over to +20. All right, so the negative number, -30 is the x-coordinate of the cue ball. That's where you first started. The cue ball is the one that you are hitting to try to hit the other balls. So the number 20 is the same coordinate as the target ball. All right, the range is restricted to 3 and 23. So let's look back at the graph. All right, so the range goes from your y values. So you can see that the cue ball starts at 3, and the highest point it gets is when it hits the wall at 23. So it goes from 3 to 23. So the number 3 is the y coordinate of the initial point, and the number 23 is the same coordinate of the bank point. All right, that's all for task 5. If you have any questions, please let me know.